Back in 1977, during the height of the space age, and amid the Cold War's tensions, NASA launched two spacecraft that would ultimately redefine humanity's relationship with the cosmos. Voyager 1 and Voyager 2 were part of an ambitious and far-reaching mission, not just to skim the outer planets, but to delve into the great cosmic ocean that extends far beyond our own solar system. What began as a 5-year scientific endeavor became a lifelong journey of discovery as these twin spacecraft traveled farther than anything humanity has ever built. Designed with the most advanced technology of the time and engineered to withstand the harsh environment of deep space, they were a tribute to the ingenuity and vision of those who built them. From the very start, the Voyager mission was a marvel of timing and planning. Thanks to a rare planetary alignment that occurs only once every 176 years, the probes were able to use a gravity assist technique where they could slingshot from one planet to the next, conserving energy while gaining speed. This allowed them to visit all 4 of the outer planets, Jupiter, Saturn, Uranus, and Neptune, something that would have been nearly impossible with conventional propulsion. This planetary grand tour was not only a feat of celestial mechanics, but also an unprecedented opportunity to observe these distant worlds up close. The first stop on this cosmic odyssey was Jupiter. When Voyager 1 and 2 arrived at the gas giant, they delivered stunning high-resolution images of the planet's turbulent atmosphere. Giant storms, such as the famous Great Red Spot, were revealed in swirling detail, their size dwarfing the Earth itself. Voyager also discovered lightning storms, complex cloud layers, and active volcanic activity on one of Jupiter's moons, Io, the first time active volcanoes were ever seen beyond Earth. These discoveries painted a dynamic portrait of a planet that, until then, had mostly been viewed through ground-based telescopes as a mysterious glowing disk. Next, the Voyagers moved on to Saturn, a planet already famed for its beautiful rings. Yet what they uncovered was beyond anything imagined. Voyager 2, following closely behind its twin, revealed that the rings were not uniform as previously thought. Instead, they were a complex tapestry of countless tiny particles, featuring waves, braids, and mysterious dark spokes that rotated around the planet in defiance of conventional physics. This shattered previous assumptions and opened new lines of inquiry into how such a structure could have formed and persisted over billions of years. Saturn's moon Titan also became a focus of fascination. Voyager's instruments detected a dense atmosphere, thicker than Earth's, composed mainly of nitrogen and methane, raising tantalizing questions about its chemistry and potential for prebiotic conditions. The adventure didn't stop there. In 1986, Voyager 2 became the first spacecraft to visit Uranus. This icy blue planet, barely visible from Earth, turned out to be a truly alien world. Uranus's bizarre axial tilt, it rolls around the sun on its side, created a strange climate system, and its atmosphere revealed temperatures as low as -353 degrees Fahrenheit. Voyager's instruments identified 2 previously unknown rings and discovered 11 new moons, each with their own strange characteristics. Perhaps more surprising was the revelation that Uranus's magnetic field was wildly tilted and offset from the planet's core, suggesting internal mechanisms that continue to puzzle scientists today. 3 years later, Voyager 2 once again made history by becoming the first and only human-made object to visit Neptune. The images it sent back were breathtaking. Neptune's atmosphere shimmered in deep blue hues, and massive storms raced across its surface with winds reaching an incredible 200 miles per hour, the fastest in the entire solar system. Even more remarkable was the discovery of geysers erupting from the surface of Triton, Neptune's largest moon, launching icy material into space. The existence of active geology on such a cold, distant body hinted at the possibility of liquid, water beneath the frozen crust, and where there's water, scientists believe there could be the potential for life. Throughout their journey, both Voyager spacecraft carried a special artifact designed not for scientific measurement, but for legacy and hope, the Golden Record. This phonograph-style disc included a curated selection of sounds and images from Earth. Greetings in 55 languages, the sound of thunder, a baby's cry, classical and traditional music, and pictures depicting life on our planet. crafted under the direction of Carl Sagan. The golden record was meant to represent the diversity and wonder of life on Earth to any extraterrestrial intelligence that might one day encounter it. It remains one of humanity's most poetic gestures, a time capsule of our existence, sailing endlessly through the galaxy. Perhaps no moment in the Voyager mission captured the public's imagination more than the now famous pale blue dot photograph. In 1990, as Voyager 1 approached the limits of the solar system, it was commanded to turn its camera back toward Earth. From more than 4 billion miles away, Earth appeared as a faint speck, less than a pixel in size, floating in a beam of scattered sunlight. Carl Sagan's reflections on this image underscored its significance, a reminder that everything we know, every person who ever lived, every triumph and tragedy occurred on that tiny blue dot. It was a call for humility, unity, and stewardship of our fragile world. As the years passed, the Voyagers continued to surprise and inform. In 2012, Voyager 1 became the first spacecraft to enter interstellar space, crossing the heliopause, the invisible boundary where the solar wind yields, to the interstellar medium. In 2018, Voyager 2 followed. Even now, these distant travelers are still transmitting data back to Earth. Despite the immense distance, signals now take over 18 hours to arrive. Both spacecraft continue to provide information about cosmic radiation, magnetic fields, and the density of plasma in interstellar space. One recent discovery by Voyager 2's plasma wave instrument detected a continuous, low-frequency hum from interstellar plasma, providing our first sustained measurement of this exotic material. These achievements are made even more impressive, considering that each Voyager is operating with less energy than a standard light bulb. The mission team has worked tirelessly to manage dwindling power supplies by shutting off non-essential systems, preserving just enough electricity to keep the vital scientific instruments running. Every year, decisions must be made about which instruments to power down. Difficult choices, but ones made with care to extend the mission as long as possible. Despite its advanced age, Voyager 2 continues to give humanity gifts, sweeping views of the solar system's edge, revelations about the outer reaches of space, and a deeper appreciation for our own place in the universe. Its instruments have transformed our understanding of planetary atmospheres, magnetic fields, and moons, sparking new generations of missions, including those focused on Europa, Enceladus, and Titan, icy moons that may harbor oceans and possibly life. Even when Voyager 2 finally falls silent, drifting forever among the stars, its journey will not be over. The spacecraft itself will continue its silent flight through the Milky Way, perhaps for billions of years, carrying the golden record, a message from a small planet orbiting an ordinary star, in the hope that someone someday might hear our call. Voyager 2 stands as a monument to human curiosity, determination, and the eternal desire to understand the unknown. For those of us who remember the launch and watched its discoveries unfold over the decades, it serves as a poignant reminder of what we can achieve when we dare to dream big and reach for the stars.